let's talk about reflections. We have two types. We have a vertical reflection. We'll generalize this in a second. Let's look at a numerical example. Let me get everything back to where it was. So, by multiplying the function by -1, notice the graph reflects vertically, meaning over the x-axis. In general, the graph of y equals negative f of x is the graph of y equals f of x reflected over the x-axis. Remember, when you're affecting the function, you're affecting the y-coordinates. So by multiplying the function by -1, you're multiplying the y-coordinates by -1. So instead of the point, for instance, 2, 4, which is where the graph was going through, you're now going through 2, -4, because you multiplied the y-coordinate by -1. Anytime you do a transformation, only one coordinate changes at a time. Again, if you affect the function, it's the y. If you affect the variable, it's the x. On the flip side, the horizontal reflection occurs when you negate the variable. The graph of y equals f of negative x is the graph of y equals f of x reflected over the y-axis. All right, so this is our square root function. Let me close these out because we don't need these. If I negate the variable, notice what's happening is all the x's negate in value. So it used to go through a point such as 4, 2, but now it goes through -4, 2, because we reflected it over the y-axis. To be honest, horizontal reflections are difficult. We really don't focus on them too much in this class. If you were taking a trig class, that's where they're going to be more important. Mainly because they're easier to do there, but not so much with our functions in college algebra. Now, this is if you have specific numbers being negative times the function or times the variable, namely -1. But let's talk about what if they weren't just -1? What if it was like 5/3? What would you have there? This is where we talk about the stretches and compression. There's a slight typo. I didn't realize that the b moved over. What are you going to do? So f of x should say negative quantity x plus 2 squared minus 4. And the b should be over here. Yeah, the b, see how the b parentheses moved over? So yeah, it should say negative parentheses x plus 2. Come on. Squared. This is not helping. Minus 4. That's a lot easier to read now. What are you going to do? PowerPoints. All right, let's work inside out. Let's first apply this x plus 2. So, well, first let's do the regular graph of the function. What does the generic graph of the function look like? X squared. So it looks like a U-shaped curve. Ugh. Hopefully it looks better than that. Working inside out, what does the x plus 2 say to do? Shift left 2 units. So this is x plus 2 quantity squared. When you have a number that's being multiplied to the function or to the variable like we have in parts A and B here, always do your k last. Otherwise, it brings bad things. So notice we have, it's hard to say, but we have a negative times the function. If you have a negative times the function, what should you do? How? Over the x-axis. Yeah, I'm just going to draw this one in because it's easier. So you're going to have a mirror image over the x-axis. So instead of opening up, it's now opening down. Hopefully a little bit better than that. And lastly, what does the minus 4 say to do? We're subtracting 4 from the function. Yep, so move it down 4. So instead of the vertex being at negative 2 comma 0, it's now at negative 2 comma negative 4. The red is the final answer. Okay. B is sadly worse. Okay, let's draw in the first graph. Your cube root function is a sideways cubic. So the black graph there is the cube root function. The thing that makes it harder is it has some inherent symmetry, so you may not see the reflection correctly. However, to get you prepped for trig, if you ever have to take that, or if you did take that, you should already be used to this. If you have a number on your x that's not 1, you should consider rewriting the function before you continue. What I suggest is pulling that number out. Now you can't pull it outside of the function. It still stays underneath the cube root. But if I pull out a negative 1 here, what quantity would I be left with underneath the radical? X minus 4. X minus 4. Much better. And then the plus 2 hangs around. That's good enough. So again, working inside out, we have x minus 4. What does that say to do to the graph? Move it left 4. Oh wait, do I want to work against that? Wait, hold on. No, I don't want to move left 4. No. Oh, right 4. Now what we're going to do, I had to remember from trig. We want to apply this number first. There it is. So if we apply negative 1, that means you're multiplying negative 1 to the variable. If you multiply negative 1 to the variable, how does it reflect? Careful. Right, over the y-axis. Be careful by saying down. That really only is reserved for parabolas. We don't have a parabola here. Yes. The thing that makes this tricky is, for this graph, notice it happens that it also appears that it reflected over the x-axis. The reason being is it's an odd function. But what really happened was it reflected over the y-axis. So this arrowhead here matches with this arrowhead here. It just reflected. We'll talk about the order of operations afterwards. You basically want to go in such a way that you don't violate what the function was saying to do. But we'll talk about that. In trig, you learn babies can buy awesome diapers. Can buy awesome diapers. Yeah. That's the acronym that will, yeah. All right. Minus 4, we're subtracting 4 from the variable. What direction do we move? Careful. To the right 4. So the origin was the center. Now the origin's going to, the center is now going to be 4, 0. Ugh. Oh, it's going to, don't do it. There we go. That works. And lastly, plus 2 to the function. By adding 2 to the function, what does that do to the graph? Up 2. So 4, 0 was the old center. So 4, 2 is now the new center. So the graph in green is your final answer.